Hello, students. This is Dr. Meeker. I'm recording this from home. It just turned the 22nd, so it's 12:30 a.m. I do a lot of my best work after midnight, I guess. I wanted to demonstrate how to make the scatter plot and get a correlation coefficient in Excel. And then I'm going to demonstrate how to make a time series plot and then do a t-test in Excel. So the time series plot is, you can have as few as 2 data points, and it would probably be best if you were to do that. Frequently, what's interesting in that case is, since we have 2 days of measurements here, you can use day 1 and day 2, or you can use of the same thing, which I'll explain in detail when I make the graph. But I'm also going to do a larger graph just to show you what the power of that is and how to do that if you need to later. So we'll start with the scatter plots and using VassarStats to come up with the statistics. And that'll be it. Let me see if I can get on to VassarStats. So I'm going to share my Internet Explorer screen right now. And so if you put in VassarStats.net into your browser, you'll go to VassarStats.net. This is not it's a user-friendly website, but in some ways it's not. So I can't share you the direct link to the page, for example, because of the way the website's written. It's written in a very old language, computer language. So we go over to correlation and regression. And we tap over here. This is also available in PowerPoint, by the way. And once we get to press correlation and regression over here and the left-hand bar, we get to this screen right here. This screen says it's correlation and regression. It basically gives you what you would call, like a table of contents in the book. You can't click on those though, because it's just giving you an idea of what's in the site. Then what you want to do is you want to scroll down to the significance of an observed value of R. Click on that link, and this is what your screen should look like right now. It says significance of a correlation coefficient. The logic and computational details of correlation are described in Chapter 3, Concepts and Applications. There is an associated free textbook that comes with this website that, if you're really interested in the details of the calculations, it will help you, and I'm sure be very rigorous and worthwhile. So where do we get our R? Because what we need to do this calculation is we need to fill in the blank of the N, which we can get that from our data set, which I'll show you here in a second, and then our blank for our R. So how do we get those values? We make a scatter plot, is the basics. So here in our Excel spreadsheet, let me see if I'm actually sharing the correct screen. I probably am not. Give me a second. Here in our Excel spreadsheet, you can see that we have 22 subjects, M001 through MM001 to MM022. So that's 22 subjects. So we know what our N will be 22. So if we want to write that on a piece of scratch paper, we can do that. That's usually a good idea. What I'm going to do is I'm going to do 2 scatter plots between melatonin on day 1, melatonin on day 2, I'm going to assume that they correlate. And cortisol on day 1 and cortisol on day 2. I'm going to assume they correlate with an individual. I could be completely wrong, because one is, for day 1, remember, in the study, they actually took this when they went to sleep, before sleep, BS. And there's a variable names and definitions tab over here on our Excel spreadsheet. If you want to click that, that'll tell you that. So the first thing I'm going to need to do is rearrange these columns a bit. So I'm going to insert a column next to the melatonin column, and I'm going to move the column of data from the melatonin column to the other column, to the blank column I just made, that I just inserted. So now I have melatonin day 1 and melatonin day 2 next to each other. This is critical for making a scatter plot in Excel, easily, at least. You can make it other ways, it's just much easier this way. And then now, since cortisol and melatonin were taken on, are similar columns in my spreadsheet, are close to each other, then they're right next to each other. So first thing I'm going to do to make a scatter plot is I'm going to highlight the data for melatonin day 1 and melatonin day 2. And I'm going to insert the recommended chart, which will be a scatter chart. Now, you can see that the screen gets a little bit busy. So I'm going to scroll down so that I can isolate just the chart that I'm working on. So remember, with a chart, it's a figure panel or a figure that will be used as a figure. So this element is going to be used as a figure when we cut and paste it into our Word. So one of the things we want to do is make sure there's no title on top, because the figure will be a figure caption in Word. Now that I have day 1, let me see here if I can identify exactly what the data is. I should be able to pretty easily. Oh, there's a 0, that will help. So there's a 0 here. So I know, because there's a 0 in the AB column, that the AB column, which is day 2, is on the y-axis, and column AA which is the data for day 1, is on the x-axis. So that's great. That just gives me an idea, so that when I want to label my axes later, or label them now, or however you want to do that. I'm not going to show you exactly how to label them, because there are multiple ways. What is important, though, is adding the trend line. So we've got this data. See, now I click on the data points, and then I right click. And it pulls up a range of choices, and I hit add trend line. So I've added the trend line. It's a little ... thing. I would suggest making it black and making it a little bolder, which you can do if you go over here. You'll open up when it opens up this format trend line over here, it will be defaulting to trend line options, because it's the first thing it wants to know is whether you want a linear, logarithmic, polynomial, moving average, etc. type. I want a linear type. And then what I really need to do the statistics is I need that R² value. So while I'm here, I'm gonna go ahead and click on that. And so I get an R² valued of 0.2038. And you can make that bigger, you can leave that on your chart, or you can decide that it makes better sense to report that within the text of your paper only, you need to report it within the text of the paper. But let's see here. Let's make this a little bigger, just because I'm mildly blind. It'll help me. And then, so what I'm going to do is I'm going to say, also, I'm going to make this trend line different. So I'm going to make it dark, black, and then I'm going to change the type of dash it is to a solid line. Already we can see it a lot better. I'm going to make it a little wider. So I go to the width and I just hit the up button there. And I'm pretty happy with that. What I'm not happy with in the figure, personally, and again, this is a personal thing, is that it is hard to see these numbers. Now, the numbers are in scientific notation because the values are so small. That can be changed in a multiple numbers of ways, but it's not my primary concern, so I'm not going to bother with that. So I change that to black, I can make it bold. I increase the font size of that axis. And then I increase the font size of this axis. And normally I like to have my axis font sizes the same. So I'm just going to do that again. That looks a little crowded. So what I can do is I can make it a little bigger, a little wider, I should say, for the figure itself or the graph itself, the chart itself. Then I'm going to hit bold. I'm going to change the there. And so I've got my R value now. So I've got my R value, and my R value is 0.2036, 0.2036. Now, the R value that I have is an R squared value. So in order to get to the R value, which is what VassarStats wants to use while when calculating your I'm going to change to VassarStats, your p-value, I need to go to VassarStats. So sorry about that. I know that my N is 22 because that's how many subjects I have. Your N is the number of subjects that you have. Now your R, we need to take the square root of, and I'm just doing this on a hand calculator. You can do it on your phone probably if you know how to get the scientific calculator up on your phone, or you can do it on the computer because you got a computer in front of you. You can do it in Excel. There are a million ways of doing it. I'm not going to go into how to do that. But what I am going to do is I'm going to take the square root of 0.2036. And my computer in my hand, my calculator, tells me that that square root is 0.45. So the R value is 0.45. And so once I put in the 0.45, I have the N of 22, I can calculate it. Now, what's really nice is that it is significant, which is really helpful because that means that there is some individual contribution to our cortisol levels, or these are melatonin levels, I believe. So that's nice. So what I want to record here is I want to record the t-stat, which it equals 2.25. First, I'll record my R value, which is R equals 0.45. And then I will record and report my p-value. So p equals 0.036. I'm going to round to 3 significant digits in that case, or 2 significant digits because the 0 is technically not significant. And then what I will do is I'll go back to keep making up this, pulling up the share thing. Go back to my Excel. I don't really care about that. what I can do is I can put the R value on the chart if I'd like to by deleting this little guy, the 2. Now I have an R value and I do 0.45. And the way I want you to report this in the text and in the figure caption, I'm going to type the exact way I want you to report this on this piece of text because it's a convenient text box for me to use. I'm going to put a semicolon. I'm going to put tstat. I'm going to hit equal. I might leave a space in between it. Some people don't. Some people do. It's a purely your personal choice at this point. And then I've got a t of 2.25, and then a p-value that equals 0.036. And I'm going to add some spaces because it looks a little cluttered otherwise. Some people take spaces out when they have to worry about how many words they're using. So I would use and put this text directly into the text of the results section. And I would put it in the figure caption here. You can leave it on the graph and not put it in the figure caption. You can leave it on the figure. I don't like that. I've done it before. It's, I think it's too busy at this point for this particular figure, but that's a personal choice. I'm not gonna care. As long as I can find it, as long as it's there, and as long as you've done the test, I'm happy. So we've done that. We're done at this point looking at the relationship between the melatonin measured on day 1 and the melatonin measured on day 2. So what we're going to do next is I'm going to make the very simple, let me make sure that I'm sharing correctly. Yep, I'm sharing the correct screen. I'm going to make the very simple bar graph that shows cortisol and the standard deviation of cortisol. So do the average. Average equals, I highlight the whole row, and you can see that the text of that is equals average AC2 colon AC23. And if you have a really lot of large numbers, what you can do is you can sometimes just, or if you have a really long column, I should say, of many rows of information, you can just go to the bottom of the column and say, okay, I'm going to take the average of this whole column. I'm going to say equals average column name 2 to whatever the number of the next row is. So I hit that, hit enter. That gives me an average of 0.02805. Then I'm going to do the standard deviation, which is STDEV. And I'm going to highlight the same column. It has the same text in the parentheses. And that's, oh, well, that's lovely because it's basically the same, almost the same number. That just happened to happen. But it's 0.0297. Now, what I will do is, because I've got cortisol day 1, cortisol day 2, they're now together, I'm just going to move this across. And when you drag it, it's going to auto-populate with the same formula, but use the reference of that column that it's just that formula is just below. Again, you can see that here as well if I click into the formula. So that's great. Now, what I need to do, there's a couple of ways of doing this now, because I'm going to do this, I'm going to try to do this the most simple way. So we've got average cortisol and then standard deviation of cortisol. And I'm just going to use Excel's abbreviations because I'm fine with that. So as you're going to see, I don't really need to know exactly what that is. Day 1, day 2. So, oops, it gave me day 1. I filled in with day 1. So day 2. Then I'm going to just type in the number that's at the bottom of that column, this number right here. You can cut and paste it. If you do cut and paste it, you have to make sure that when you cut and paste it, you paste numbers only. But I find it easier sometimes, especially when I'm a little on the tired side, to go ahead and just type it in. And you can, I'm going to use 3 significant figures. It's not that important in this particular project. It can be important in some projects, how many significant figures you use, but in this case, it's not. 0297. Okay. Then, oops, so I put that in the wrong place. So that's the standard deviation. So one way to help you, if you're tired like I am, is you can label your rows, because you're going to make your rows columns. And when you make your rows columns, that's actually a mathematical operation called transposition, or transposing, or taking the transpose. Now I'm talking and trying to type, and that doesn't always work for me. Standard deviation. And that's, so you can, so now I have the standard deviation. I'm going to put the standard deviation over here, 0.0297. And then I've got the average of day 2, which if I really need to check it, I can go back up and look at the top of my column. You can use Excel to freeze column headers, which I've done with the row, or the first column. So the first row you can freeze, and you just go up to View, Freeze Panel, Freeze Panes, and then I'm just going to say Freeze Top Row. And now, of course, it only froze the top row and decided not to freeze my. Let me see if it actually did that. Oh, it did not. Yeah. So I had my subject row here frozen too. So I got unfreeze, and then I'm gonna freeze rows and columns. So maybe that. Whoa, that's not what I want. Give me 1 second. But anyhow, so that gives me an idea. So average, standard, deviation. Okay. So this looks a little weird because I've got my front part, my first 5 column, first A through L columns frozen, which is not what I wanted to do, but I don't really want to take time to fix it because I think it might be more confusing going through fixing it. So, okay, so day 2 value for average cortisol is 0.0699. So I'm going to round that. And then the standard deviation for day 2 cortisol is 0.0519. So now I've got these 2 guys. I am going to have to unfreeze everything there. Okay, now of course it takes me out of what I wanted. Okay, so I've got this data here, and I've got it arranged like this. I've got average cortisol, standard deviation of cortisol, and I've got my row labels here, day 1 and day 2. So what I do is I highlight these first 2 columns, the label, named label column, and the average cortisol column. And then I insert a figure, and my first recommended figure is going to be a bar graph that looks like this. Again, we want to remove the chart title because it's unprofessional to do that. The nice thing about this is that you can see that the names that you put here in your first column for its labels have appeared under your bars, which is great. Again, I would modify the font just to make it look a little bit prettier, but that's not a criteria for grading, and you can do that if you want to. What you do need to add is you need to add error bars of some sort. So I go up to chart design. I click on chart design. At the top, I click on add chart element. I go to error bars, I go all the way down to more error bar options. And then I'm going to specify a value using custom error bars. So you can see here, I hit specify value. It starts out with a 1, which is why those are so big. And I'm going to highlight the standard deviation column that I've created for both the positive and the negative. And I'm going to hit OK. So those are pretty big error bars. We expected they would be pretty big. You can't really see them that well. Again, I would make them a little thicker, which you can increase the width, change the color from that default dark gray to black. You know, you can do all kinds of things, change all kinds of things you can play around with in Excel to change the format. But this is sufficient, I think. I don't like these lines because they look weird, so I just take them out. You can just, all you have to do there to take out the lines is you click directly on one of the lines. It highlights all the lines. If all the lines are highlighted, I just delete. You can make these bigger. It is what it is. Now, that is making the bar graph figure. So that's actually figure 1. So I made the scatter plot first because I thought it was the simplest, especially when you're doing the statistics. So speaking of the statistics, we want to do a t-test on this data to see if there's a significant statistically significant difference, or any difference at all, if depending on who you're talking to. So what we're going to do is we're going to hit equal t.test. And the thing that is nice about that is that it tells you that it returns a probability associated with the student's t-test. That's helpful. When you hit the opening parentheses, it's going to open that parentheses and it's going to tell you what it's looking for data-wise. It's going to say, I want array 1 and array 2. I'm going to want a number that tells me something about the tails and a number that tells me something about the type. Array 1 is one of your data columns. So I'm going to use for array 1 the cortisol measured on day 1. I'm going to hit the comma. It's going to automatically take me over to day 2, or the array 2, which is day 2. I'm going to hit the comma again. And when I hit the comma again, it says one-tailed or two-tailed distributions, really small font. What you're going to hit is 2 because you always want to use a two-tailed distribution, unless you really know that there's a difference and you have that difference that you know that that's from the literature, that's definitely a difference that you're going to see. So I hit 2 and then I hit another comma, and it gives me a choice of 3 different types of t-tests. You can have a paired t-test, a 2-sample equal variance t-test, a 2-sample unequal variance t-test. So we have the same sample of individuals. So we're allowed to say it's paired. And if you take other statistic courses or other research courses, you'll find out that that's preferable. If you can do paired, do paired. So I'm going to do paired. I put my 1 in there. I close my parentheses. I hit enter. And because my recording thing is weird, it gives me a p-value. This is the p-value that it gives me of 0.0010469, whatever. You don't need to report that. But so what we can put in our paper is say, okay, the t-test reported a p-value of 0.001. And that's statistically significant because if anything is lower than 0.05, we've decided as a group that that's a significant difference. So if you look up in this bar up here, it says, this is how I did this test. T.test AC, open parentheses, I put my array of column 1 data. I put my array of column 2 data, which is day 1 and day 2 cortisol levels, respectively. And then I chose the type and the paired. And then I hit enter. So this is the valued report for your t-test. The t-test told us that it was significantly different and our p-value was equal to 0.01. That's all you need to do. And that's all I'm going to go over for this. If you have other questions, come visit me. My office is Key Hall G51, right next to our classroom, basically. And my email address is timothy.meeker@morgan.edu, which is in the syllabus. Thank you very much.